Hello, and welcome back to the System Design series. At a high level, we can categorize the design goals into 5 different categories. In the previous video, we covered performance-based design goals. In this video, we will continue and dig into dependability-based design goals. Dependability. This category of design goals helps us to make a system more reliable from an operational standpoint. So how can we describe dependability? Dependability refers to the effort required to minimize system crashes and malfunctions by making the system more available, reliable, and fault-tolerant. This category has many criteria that we can look into in order to define the design goals. Scalability. Scalability refers to the ability of a system to handle a growing amount of work so as to accommodate that growth. Let's say that we run a social media app supporting about 10 million users. We run a query to find out the details about the friends of the user, which involves joining multiple tables to retrieve the results. The response time for the query is say 1 second. But as the number of users grows over time, for example to 15 million, we start to see that this query starts to slow down. It now takes 3 seconds. As we reach up to 25 million users, now the query takes about 10 to 15 seconds, which is not acceptable. So the question becomes, how can we solve this problem? And how can we make sure that we can get the same response time as before? This is a classic example of scalability problems where a system is not able to keep up with the same throughput or the response time due to increase in load. We can improve the scalability in several ways, but most commonly, we use the basic vertical scaling and horizontal scaling approach to address it. Vertical scaling. This involves increasing the resources such as the CPU, RAM, or storage of the single machine so that it can handle more workloads. Horizontal scaling. This involves adding one or more machines to the system so that we can distribute the workload and handle more requests. In our use case, we can try to use vertical scaling. We can increase the resources of the database server to the maximum level that is allowed by the machine. That may buy us some time, but eventually we may have to resort to horizontal scaling as we grow. We add more database machines that can replicate the primary database across more than one machine. This distributes and offloads the processing, thus reducing the response time for a query. We can use other techniques like load balancing, data partitioning, caching, etc. to increase the scalability of our system. So a design goal should be to architect our system in such a way that we can scale a system as we grow. That is, we want to optimize for high scalability. Security. The criteria for security refers to the ability of the system to withstand malicious attacks. These set of design goals are important as they protect our system from hacks and prevent unauthorized access. Let's review the criteria by asking a few questions. Question 1. How do we plan to secure our servers? We can secure our servers with firewalls and other system hardware and software companies to avoid such attacks. Question 2. How do we plan to secure our API and services? We may choose to secure our API and services using JWT access tokens and other authentication mechanism and authorization schemes. Question 3. How do we store sensitive data at rest? So we can choose to encrypt data, which means that it has to be unencrypted before it can be used, thus increasing response time for our service. Such concerns would lead us to define security goals that would make sure that a system is more secure. Robustness is defined as the ability of the system to cope with invalid user input. We are all humans and we make mistakes. Likewise, the users of a system can provide invalid input data, and that can cause a system to malfunction and not work as intended. For example, let's say a system requires the customer provide a payment before the orders can be shipped out. In the order submission flow, we enable our customers to provide their credit card or debit card that will be charged for the order. However, when we are ready to ship out the order, we attempt to charge the payment method and it fails. The failure can be for various reasons. The credit card number could be bad to begin with, the card may have expired, or there may not be sufficient funds on the card itself. So our system failed to ship the order to the customer because we could not successfully charge the customer. But we can design a system that allows the users to fix or provide a different payment method. We can also do upfront validations to make sure that the payment method that the customer provided is valid before even we accept it. We can notify the customer about the failed order, and then they can provide a valid payment method which a system can pick up again and use it to charge this customer. This will create an order that will be shipped to the customer. This would imply that a system is robust. That is, it can handle or self-correct and cope with invalid user input, which would lead to better customer satisfaction. As a design goal, we should design a system to optimize for robustness by making sure that the invalid user input can be handled. That's all for this video. In the next one, we will cover other design goal categories, namely cost, maintenance, and end user criteria. Please subscribe to our channel and click on the bell icon to get notified whenever a new video is posted. Till then, keep learning, and I will see you in the next video.